Hello friends and welcome to my channel. In this video I will repair this public address amplifier. Let's begin. First of all, let's take a look at this amplifier. First problem is that this potentiometer is fault and I have to replace it. Second problem is that this main fuse is also fault, and I measured these power transistors and at least one of them is in short circuit. Unfortunately, this is not repair friendly because we don't have access to the back of the PCB, and that's why I have to disassemble all piece by piece. Let's begin. Now you can see the PCB. As you can see, those two power resistors seems to be fault. And now let's measure power transistors. Short, 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 this is good. These power resistors the values seems good, but they are not in parameters because was overheated. Now let's measure these power resistors. Good, good, good. Now, because these power transistors are all in parallel, I have to take down to measure it. Those two power transistors show us short circuit on collector emitter. Those two shows us short circuit also on base, and all three terminals are in short circuit. And for the beginning I will take out only two these power transistors. Now let's measure these transistors. This is not short. It seems only this one is in short. Because short is complete on all three terminals, we should check the resistor who enters in the base of this power transistor. Now let's check those two power transistors. Another one is in short circuit. Now let's take out. Now let's measure the other two. good. This is in short. So this is bad, this is good. This is good. And this is bad. To be sure, let's put this on a tester. It's good. This is also good. Now let's check the rest of the PCB. First of all, the base resistor of this it's good. The base resistor of this second transistor should be the same value as the first one. Now you can see this this is fault. We should repair this. These transistors are not in short. Now let's test all these resistors who are related to the power transistors. All these small resistors are good. Now let's check again these power resistors, because with short circuit on power transistor, this also can be fault. It's good, good, good. All are good. Usually when the power transistors are in short circuit, at least one of these power resistor is interrupted when it's good design of the schematic. As you can see, I will replace this power resistor, but just after all of this is working. Now I've replaced all the bad fuses, and I will power this up without the amplifier board. And now let's check the supply voltage. Supply voltage is good, it's 34 volts. Now let's discuss about the schematic. Usually, public address amplifier are made in Class B amplifier push-pull configuration. Simplified, it looks like this. As you know, public address amplifiers output will not be on the speaker, will be on the transformer. On the output of this transformer, we can use 4 ohms, 70 volts or 100 volts. This on the primary part. In the middle we have plus 24 volts. Now we have without the load we have 34 volts, but with the load voltage will be approximately 30 volts. So here in the middle we have the power supply, and this 2 power transistor. On my PCB there are 4 power transistors, 2 in parallel on each branch. So in upper sinus, this will conduct and will apply this transistor will close and will apply voltage on this side on the transformer. When we have a lower sinus, then this transistor will close and will apply this way. And on the output we have upper sinus and low sinus. This push-pull configuration is equivalent like we have plus and minus 24 volts like in Class AB amplifiers. Now I will put the PCB in the amplifier, but I will not use the original power supply of the amplifier because it's too powerful. I will supply with my lab bench power supply with current limiting. Let's see what happens next. I put the PCB back so I can connect the output transformer, and I will apply supply voltage from this output power supply. I have 25 volts with 0.5 amp. Now let's see what happens. I have only 5 volts and 0.5 amp. This shows us that somewhere is a problem. And if I connect the power, this power transistor will blow again. Now I have to check and found the problem, because the output transistor get fault with a reason. I will go up to 1 amp to see what happens. Even I put 1 amp, the supply voltage is limited to 6 volts. So we have a problem. First of all, I have to put the minimum, the bias current. Let's measure the voltage on this output resistor. The voltage, it's too big, and that means these output transistors are closed now. Let's see what happens. Let's see what happens when we play with the bias current. I adjust the bias resistor and nothing happens. I will have to check the schematic and the PCB. Maybe this isn't bias adjustment, like I suppose. So, to be sure, I will connect all this input to be sure that it's not a malfunction because this missing. I will close the power supply, and now let's see what happens when I put this back. Now I connected all back. Let's turn the power on. The output voltage increases to 9 volts. Let's increase the current to 1 amp to see what happens. It's also current limiting to 9 volts. That means we still have a problem here. I will take down this PCB, and instead of this output transformer, I will put a load resistor to see what happens. Now I connected the supply voltage to the amplifier PCB without the load transformer to see what happens and see if the problem is in the power transistor part or in the current or in the voltage. Now I will power. Now I have 25 volts and 0.09 amps. So it seems the problem is here. Now let's measure the voltage on the output transformer. This is good, and this also seems to be good. Ah, now I see. Here should be 25 volts, but because these power transistors are closed, now here we have ground, and if we put the output load, then the current consumption will pull down the supply voltage. Now let's check the base of the power transistors. This is good. This is good. This is good. Let's check this. Here we have I will have to put a load. To see what's the problem. Now I mounted this power resistor to emulate the output transformer. Now let's connect the power supply and let's see what happens. I have voltage limitation on 12 volts at 0. This is hot. That means these transistors are closed and all the power goes into these power resistors. I will have to decrease the current. Now let's measure base emitter voltage. As you can see, it's full. Let's measure this voltage. This seems to be the bias current. I put it to the minimum. When it's to the minimum, now the voltage it's 25 volts and the power consumption is 0.09 amps. And there is no voltage on the output. Now I'm looking at the power supply. And when I increase the current, the supply voltage is getting low. Now when it's to the minimum, it's good. everything seems to be okay. I will put back to see what happens. Now let's turn on the power supply. I have 0.7 amps current limiting, and I have 25 volts and 0.2 amps power consumption. Still, I didn't mount the power transistor on the heatsink because I want to make some tests. Seems to be good. Now let's make a sound test. I put the PCB inside. I connect this speaker. I put this music, and there is no sound. I have to check again. There is some problem yet. Now, because I don't have the schematic, I will try a different approach, and I will check the audio signal in some points. First of all, this is input. We have audio input signal on this. Now I will test this potentiometer for that connector. So at this potentiometer we have signal. Now let's go further. This bass, treble and volume potentiometer. So it seems here we have signal. On this board we have signal. From this board signal goes back with this connector, and then from this connector goes to this module from bass, treble and volume, and somewhere between these two the signal is lost. Now I will take off the PCB and I will check that part. Now I will tell you what I did. I took off this PCB so I can measure. I follow the audio signal from this potentiometer, goes on this connector. From this connector goes from this IC, it's an op-amp. I measured this op-amp and I noticed that supply voltage is very low. It's 3 volts instead of 15 volts. And I also noticed that this resistor who is getting hot, it's from the supply of these 4 circuits. They are supplied from same point. And then I make a short from this point, power supply of this IC, and I put on my lab bench power supply. I adjust to 15 volts and 1 amp current limiting to see which one of this IC is getting hot. I will turn on. This one is getting hot. Also this one, this one is not getting hot. So these three ICs are having too much power consumption. I will have to take this out, all three of them, and see what happens with the current if I take this out. I took off this IC, I put the ground to the 4th pin and the VCC to the 8th pin. And when I make this, I have a very big power consumption. It's 0.3 amps and this is getting very hot. This is not a good sign. I will have to replace. And on other three ICs, I just desolder the 8 pin VCC supply to see what happens. And I noticed that power supply of this IC is now it's good, and this power resistor it's not getting hot. Now I will replace all for this IC. Now I took off all the op amps bed from this PCB and now I will replace it. I've replaced all 4 op amps and now let's make a test. This is the input. This is the line potentiometer. This is the bus. We have signal. This is the signal. And this is volume. As you can hear, we have signal here. Now I will mount back together to see if we have signal here on the speakers. Now I put all together and now let's make some test. As you can hear, it's working, but I have to replace all these potentiometers because they are not in good shape. And the sound quality is not perfect because the signals passes from this transformer and it's a loss of quality. Now I will replace all the parts. I will fix this on the heatsink, and I make some tests from original power supply. Now it's working from my lab bench power supply to be sure that are not other problems. I've replaced the bed potentiometers, this line and from volume. I connected the original power supply, and now let's start. I forgot the volume to the maximum. Meter, it's working. Now I can't give maximum volume because I didn't fix power transistors to the heatsink. It seems it's working fine. Like I told you, it's not very good fidelity. This public address amplifier are used when you need to put 20 or more speakers in parallel. And usually if you have one speaker with 8 ohm impedance and you put 20 in parallel, you will have two smaller impedance. And that's why when you need to put more than 10 speakers on one amplifier, we use this system public address. That means the output it's 100 volts peak to peak, and you use a step down transformer to use usual speaker like this. I can emulate this. If I can put a transformer, I put transformer on this output, and primary on this output, and secondary I can put on this speaker. Now I will repeat what I replaced. I replaced two of these power transistors, and I replaced these four op amps that are connected, that are supplied from this power supply, because these two op amps are supplied from this voltage regulator. And I don't know why this got fault, but I presume it's a problem or on the input or voltage peak when this transistor got fault. Maybe a peak of voltage reached here and override the maximum supply voltage that they can manage. If you have any questions, please put it in a comment. If you made it so far, please give a big like and subscribe if you want to learn about other electronic devices. Thanks for watching. Bye.